Hello Natroners, and welcome back to another episode of VFX with Natron. So, today we're going to be looking at making we're not going to make particles quite yet. We're going to actually work on making particles. We're going to be making 3D, try to at least make 3D particles. I had a demo loaded into Natron. Unfortunately, just as I started the stream, it crashed. So I had to relaunch everything, and I don't have it up. It didn't save it in the emergency backup file. So it is what it is, and we'll just start from scratch, and we're just going to pop over into Natron and start at this. All right. So, 3D. We've simulated particles before, and I got to just move a cable out of my way because it's banging into my leg. Oi. And this has been a crazy week for me. So, lots of things happening. So I haven't been as prepared as I usually like to be. Well, it might surprise people. Anyway, yeah, so 3D particles. We've done particles in the past. We've done them in birding. We made snow. But a lot of people have asked me, hey, Bill, how do we make particles that are 3D? Because there's several examples of 3D effects that people have wanted, including Mr. Thomas Morley. He's asked many times about doing 3D, and he asked it almost a year ago, and I've been investigating it and looking into things, and I think I've got a pretty good way of approaching this for people, because it's a very, very tricky part or task unless we resort to shadertoy. And the problem with shadertoy, as we all know, is that shadertoy, when you start getting into complex stuff, it can get iffy. At least in the current versions of Natron, it's not always the most reliable thing in the world and can cause issues. Anyhow, we would rather get something that's stable, almost guaranteed to work, and looks like particles. So in Natron here, what we're going to start with is we need a shape, and because we've been talking about rotos and so forth, I thought we would just start by, well, first let's start with something really simple. And we're going to use some techniques we've used before. Sorry. We're going to first put a radial in here. R-A-D, or R-A-D, R-A. There we go, radial. And we're going to start with this radial. And we're going to set this, let's set this down to 1 property at a time, and then we're going to set this down to let's just set it to 1080. So, and then we'll center it. All right, so why have I picked a radial over something else? Well, what we're going to do here is examine something we've used actually in the very, very first episode of VFX with Natron, which is, you know, the gimmick 3D extrude node. So we're going to go we're just going to do extrude, E-X-T-R-U, and there we go. Gimmick 3D extrusion. Now, as people might remember, this node by default, when it has an input, doesn't do anything unless we go into the advanced options and we first have to enable it to render, and it doesn't render to layer 0, it renders to layer 1. So when we do that, it should start rendering potentially. Actually, well, let's enable, I think we also have to enable preview draft. All right, it's not, oh, you know what? It didn't hook up, that's why. Oi, that would be why we didn't see anything. Okay, so we have an error. The problem is of course, Gimmick, of course, does not like to work with things that do not have a bounding box that matches the bounding box of our output resolution. It's a really annoying bug. And at first you don't notice it. All right, so what we need to do is, of course, we need to create something like a solid. And then we're going to merge the solid with our radial, because as we can see, the radial's bounding box being 1080 by 1080 is not the same as our output resolution. So if we look at that, once we've merged the two and we set it so that the output of the merge node is the bounding box of B, that will fix it so the radial will forever now be the size of that. And then when we connect it, we can see, all right, there's something. We have something. And let's go back. Let's start this off. Let's look at the gimmick node. So the gimmick node starts like this, or pretty much like this, minus the fact that, and I want to just make sure, don't know if you guys can see it. What I'm going to do, I'm going to switch this. I don't know if that shows up. I'm worried that it's not showing up. We want to switch where it says output layer from layer 0 to layer 1. And when we do that, we can see that that causes it to draw, but it's not proportional. It's actually squished vertically. So then what we have to do, and I'm going to try and minimize this as soon as I do it, we're going to click on preview draft. And I don't know if that's showing. It looks like it is. We're going to just click on that, and you can see that now it's stretched it vertically. And I'm going to just minimize this so you can see. So you want output layer set to layer 1, or -1 technically, but it's layer -1. And then preview draft mode has to be checked. So if you do those might be hidden behind my face. You'll wind up with this. And now this doesn't look like our radial. It doesn't look like our radial in 3D at this point because it's not very deep, and it's not and it does, and we're at an angle. So what we're going to do for right now is let's reset our angle. So we're going to set our angle to 0 for the X angle here on the gimmick node. Set our Y angle, we're going to set this to 45 because I want to look at this at a 45-degree angle so we can see the depth that we add to it, and we'll set the Z to 0 as well. All right, so what Y is going to do is it's going to rotate it 45 degrees, so it's sort of like at an angle like this. Now we're not seeing very much at this point because it's also not very deep. This is very thin. In fact, let's set this to 90 degrees, and we can see if we change the Y to 90, we can see that it's actually really, really, really thin. So that's because the depth is 10. What we want to do is increase this depth quite a bit for right now. And as we bring this out, we can start seeing something that didn't happen when we were dealing with text in the past, which is, this is rounded. And you're saying to yourself, wait a minute, this is rounded? It's curved? Why is it curved? Well, some people might think it has something to do with the smoothness of the smoothness setting here, and it does to a degree have something to do. The smoothness control does affect this. If we set this, for example, to like 1, we can set this, actually we can reduce this down to 0, which has no smoothing on it, but we still wind up with smoothing on it. So why are we getting smoothing here? That's one of the first things we need to investigate. And if we put this up to a nice big 250, we wind up with something, it's not really spheroid, but it is as close as we're going to get. And this is, we don't need this to actually be spheroid for our purposes. What we want to do is look at the fact that of what's going on here and what is happening and why this is curving like this. And the answer to why it's curving actually comes back to our original radial. If we look at a radial, we can see it's gradiated, and very much like the extrusion, the shadertoy extrusion that we've used, Croc and Boss, excuse me. By using this, we also get the same kind of effect. It is affected by the gradient on it. So the darker it is, the further it goes back. So this means that if we have something that has texture to it, we can effectively use that. We can use grayscales to bump, or to actually not really bump, but we're going to use it as displacement, or part of the extrusion process. And that will allow us to create fundamental rudimentary shapes that are going to function in 2 dimensions, or on 2 ways away from the center point. So right now we're just doing this with a radial. So what we're getting is the radial's curve is coming up and out, and then over here it's coming up and out in the opposite direction. And we can rotate around this, you know, depending on how we rotate this, we can see we can rotate all the way around this. Well, this is good. This means we can actually rotate this thing fairly easily. In fact, let's do that. Let's add a little bit of animation to this right now. First of all, let's lower our render resolution a little bit so that this doesn't take forever to do. And let's also lower the resolution of some other things here. So let's talk about some things we haven't talked about in the past, which is, first of all, what is this little resolution thing up here that says 512? Well, this 512 is actually how many... it's not really exactly how many polygons are in this. It's an approximation of how many polygons. If we switch this from Giraud or Garrod, or however people want to call it, to flat shaded, we can... Whoa, that really changed significantly. That's very weird. That's actually very, very weird. Let's just... that shouldn't have changed like that. That's... Huh. Well, let's drop that back down. All right, that was just a render. Oh, you know what it is? It's because we dropped the resolution. All right, that's why. All right, we're not going to drop the resolution quite yet, till we go to actually animate it. So if we go from Giraud to flat shaded, we don't see much of a change right yet, because our resolution is still very high. But if we bring our resolution down, if we start bringing this down, we can start seeing, you know, banding start to occur in this. I don't know. There we go. Once we get it down into the sub 100 level, we start seeing the actual polygons of this, and we can start seeing interesting stuff. And as we rotate this, we can see this is a much simpler shape. And it also is rendering significantly faster. And this is really important if we're going to be making things... If we want to make particles, we want things to, you know, we're going to be doing something and we need it to render very, very quickly, or as quickly as possible. So the goal here for a particle is to try and get some simple 3D shape that renders very, very, very fast. So what we're going to do is just keep dropping this down. We're going to drop this down even more. We're going to drop it down. Oh, that's actually pretty good. We got something that almost looks like a gem of some form at this point. So you can see it's very, very, very simple. And this is all we really would need for a particle. However, this is not that exciting. Now, I just want to bring this up from the standpoint of, if people want to do something more complex, let's see what we can do. I'm going to bring in something I've already made. I'm going to just bring over an SE, 2 SE noises. Well, let's look at this for a second. All right, so here I have an SE noise, and we've seen this. This is a Voronoi. And we have 2 Voronoi. They're the exact same thing. We have this Voronoi here. We have this Voronoi here. And what I'm going to do with the first Voronoi is I'm going to go into the clamp node, and I'm isolating the highlights. And how am I isolating the highlights? Well, I'm changing it, so I'm setting it so that the extremes are clear, or that we can you know, basically drop everything below our minimums back down to black. So by default, we can see that if I don't, it's clamping this value here to whatever, which is the minimum. It's very close to 1. So anything that's above this will get basically clamped to white, and anything below this value will be clamped to black. So we can see, if we look at our original thing, the brightest thing on our entire polygon here, or on this entire SE noise, and by the way, you can see that I've offset it a little bit. I changed the scale. This is our brightest, our brightest shape or piece element of this. So what I do is, by turning that into this, I've isolated it, and I can use this as a mask. Okay, so I'm feeding this mask into this merge node, and then I'm going to be using it as a mask for this Voronoi, which what I'm going to do with this Voronoi, which is just the same exact Voronoi, but the difference is, instead of being type 1, I believe it was, or no, what was it? Was it? Yeah, okay, excuse me, Voronoi type cell, which is the default. We're going to switch it to Voronoi type 3. And by turning it to Voronoi type 3, we get this, well, we get this shape. And then what I did is I went in and I put a grade on it, and I changed the gamma down to 0.2, which makes it a lot more visible. It makes it this shape. And when I merged these two, when I put this pattern mixed with this mask, I wind up with this shape. Okay, so if I take this shape, and let's go back to our thing here, and we go back, let's go back, way back to the, oh, actually it doesn't matter where we are. Let's set this to 0, and let's reset our resolution to default, just so we know. If we plug this into the other, what we wind up with is this shape, which is very different. Very, very different. In fact, let's take a look. Let's just kind of scrub around this for a minute and take a look at what we're getting here. We're getting something very, very, very different from what we had before. As we can see, we wind up with something that has a really interesting shape. So we're basically getting, and I would argue that this 250 is too much for this. In fact, I would drop this down to probably even 50 is probably enough for this particular shape to work, as if we wanted to keep this as our, as our polygon shape. So we could use this shape right here as a particle if we wanted to, or potentially as a particle. So you can see this is not going to be limited to just doing simple poly shapes, but if you do something more along like these lines, where you define a shape, it might take, this is going to take, if we watch this, it's going to take a lot longer. So what we would want to do is probably drop something like this down in resolution, even to closer to, look at this, to around 100. Even at 100, we're getting a lot of broken up. If we look at this really close, we can see that there's funky things happening in here. It's looking a little weird in here, and broken up, and it's not shading quite right. Let's try and look at this full screen. Oops, excuse me. Wanted to hit spacebar. Let's hit this full screen. We can see that we can see patterning breaking on this as how it's tessellating it. Tessellation is the term used when you take something that's two-dimensional and you make it into 3D, and it interprets that displacement and turns it into polygons that represent that two-dimensional shape in 3D. Is a form of tessellation, and we can see the individual polygons because it's not really smooth. But we can, if we're making these really, really small, this is how if we were to shrink this down. So, whoops, if I take this, and I'm sorry, I want to let's put a transform on here. And if we were to scale this down, significantly, by the time it was down to, say, 1% of its size, if we view this full screen at full size resolution and turn off those overlays so we can actually see it, we can see that none of those tessellation artifacts really show up if it were this size. So from the standpoint of this being a 3D shape, this is probably perfectly fine, at this tessellation level. And it will render much, much, much faster than if we had kept it at its full resolution. So it's very important, if you're going to do particles using this node, that you get used to the idea that we're going to want to actually, let me disable, whoops, no, Let me disable that, and that way we're looking at this at, oops, there we go, at this resolution. So so that's one of the things that we want to do. The other thing we can do is we really don't need this rendering out. Right now, it's rendering out the outside, or the shape that it's using to do the tessellation is also being rendered at a scale of 1000 by 1024 by 1024. Well, we probably don't need even that much resolution. We can probably drop this down quite a bit as well. In fact, let's drop it down to like 200 by 200 and take or around there, 200 by 200, and take a look at this. And we can see the width and height. Really, we're getting this way down there, and we're still retaining enough detail on this that we're getting a decent enough shape for this to be representative. And now I'm pretty sure this is the actual resolution of the map. I actually am not positive, but I was under the impression that's what this was. I could be wrong. The more I'm doing this, the more I'm thinking this isn't the resolution of the map, because we're really dropping this down in size. I think that either this is not linked up currently, or it's having less of an effect than I thought, or a very big possibility. No, we're rotating around. It's still working fine. Well, I would drop this down because it is going to affect our basically everything. So let's drop this down and get our tessellation down to something very reasonable for the shape. Let's see. We could say, this is almost good enough for basically any shape. So now how would we rotate this if this were going to be a particle? All right. Well, we wouldn't want to do it obviously on a transform. What we want to do is do this with a on the actual card 3D itself. Now, what we need to do, because we want this to be a particle that spins, we want to basically make this so that it can repeat itself, because we're going to be treating, instead of actually using this 3D object and rendering thousands of individual objects, what we're going to do is do some trickery. We're going to actually use we will use a few gimmick nodes with possibly different shapes. But we want to, what we're going to do is we're going to treat it as if, in fact, I'll just, because I don't want this, I just am curious. If I drop this down to like 2, now 2's too low. Let's try and get this down to a nice simple shape that's a little close but not perfect. All right, that looks like a chunk of something has just flown off of. I would buy that that's a chunk of a piece of an element of something that had blown off of like a piece of text or whatnot. Anything that I wanted to explode in Natron and make it look like it was a 3D particle coming off of it, that is how I would make it look, or what I would use, something along the lines of this. Very simple, very basic. All right. But we need to make it rotate. So we want to make it rotate, and we want to make it rotate based off of an interval. So what we need to do is determine how many frames we want this to basically do one full revolution. I would recommend some multiple, something that can be divided multiple times fairly easily. Now, we could say, if we do we're doing a frame rate of 24. If we say we want to have this revolve around, rotate once every second, then what we need to do is we need to basically come up with multiples of 24. So, all right, well, let's set an expression here. Let's take our x, or actually, let's start with a y angle, because we'll edit our y angle. Let's set an expression here. And what we're going to do is inside of parentheses, this will make sense in a bit. We're going to do a frame, which is basically we're going to take whatever frame we are on, and we're going to divide it by 24. All right, or actually, is that right? Let me think about it. No, frame times 24. Excuse me, times 24. All right, so every frame we're going to rotate this by 24. All right. Let me just think about that. Is that correct? No, what we need to do we need to make it frame times 360 divided by 24. There we go. All right. So that's our first thing. All right. So that means in 24 frames, it is going to do one full rotation. But the problem we have with gimmick nodes is gimmick nodes only go out to 360. Once we get to here, let's take a look at what happens if when we actually start rotating this. If we start playing this and it renders around, we'll see that once we pass frame 24 in our rotation, we're going to have a problem that it's just going to stop. So why did it stop? Well, the problem is that the number now is higher than 360, but gimmick only supports 360 degrees. So we need to use a modulo so that it resets to, after it passes frame 24, it's going to reset to 0 at that point. So we're going to go to our expression, edit our expression, and then we're going to put a percent sign, which is modulo, and then 360. All right. So what that's going to do is, as we can see, is it's changed the result on our current frame. Without this, let's get rid of that for a second. It's 435. If we do modulo in here, and then we do 360 for what we're going to say, now it changes it to 75. So if we go back to the beginning and we hit play, what that's going to do is it's going to make it now on this whole thing, it's going to loop every 24 frames. It's going to loop or it's going to loop basically 360 degrees, and it's going to do this continuously forever and ever and ever. All right. So there we go. There's our first number. Now, let's see. What is the next thing? If we were to divide it in half, that would mean we would have 12 frames. All right, 12 divides into 24, nice and even. So I'm going to say on our X angle, we're going to set an expression here. And we're going to do the same thing. We're going to do frame times 360 divided by 12, right? No, divided by, is that right? What we want to do is we want to do divided by 24. Just thinking about this. I want this to happen in 12 frames. So I'm going to take the result of that and I'm going to divide it by 2. Oh, divide it by 2. No. Is that right? No, it's going to be, we're going to multiply it by 2. So it would be, because we want it to happen twice as fast. So we actually want this to be, instead of 360 divided by 24, we want it to be divided by 48, I think. Is that right? Something. We'll try 12. We'll see how this will either work or it won't work. I think that's not right. Well, anyway, we're gonna give this a shot. All right, so 360 divided by 12, and then we're gonna say modulo 360, which puts it there. Let's take a look at that. So, boom. Let's take a look and see if that works. So now we're getting something that looks like it's rotating around a lot better, and we should get 2 full rotations out of that. I think that 24 divided by, I think we can do, me math skills are terrible. Anyway, we can see we've got, we've got something that's looking like a particle that's spinning in 3D. All right, now we need to do one more. I'm going to pull up a calculator here. Let's do, all right, so 24 divided by 3. I think we can divide by, yes, 8. Good, awesome. So we want to do 360 divided by 8, I think it is. So set an expression on the Z, and we go parenthesis frame times 360 divided by 8. in parenthesis modulo 360 to get us our actual thing count, and that should be, I think that's going to give us our fastest rotation of a mole. So then we wind up with something that basically looks like this. Now we can see that it's going off the top of the screen here, which means that we do have a problem, which is that this is too small for what we're doing at this point. But we have something that could, for other than the fact that it's getting cut off at the top and the bottom, we could use this shape as a repeatable. Oh, it might be a little bit too fast. You know what? We need to double this. All right, so let's edit this expression. Let's, instead of 12, we'll set this to 24 for this. And then we're going to edit this expression. We're going to tell it, instead of 24, we're going to just double it. We're going to take everything. We're going to set this to 48 frames. And then we're going to set this, edit this expression, and instead of 8, we're going to set this to 16. I think it's 16. Yeah, 16 should be fine. All right. So then we go here and we'll hit play, and this should end 48 frames. So we're going to use a 48 frame cycle instead for our particle, and it hopefully won't look as, this will look a little slower, but we should start, this should start repeating at frame 48. So if we stop this and go back to frame 48, or actually I think it's going to be here at 49, we go back to frame 1. All right, let's set this to 48 frames. 48 frames. Let's go forward. All right, let's see the next frame. From here, if we go back to the beginning, they should be darn close to identical. It's not perfect, but it will read, from a standpoint of this animation, this would read as a completely loopable thing. So, all right, how can we make this fit? Well, we need to, let's see, we need to shrink this a bit. Let's transform this. Let's deselect this, and let's zoom in on this. All right, so we have a problem here, which is our animation is getting shrunk down to the size, or to a size before we actually have it. So we need to, let's try shrinking it down before we add it. All right. It needs to be, of course, we're scaling it down, so of course we need to do the same thing where we put it through. All right, so the problem is of course, this, by scaling it down to that size, the bounding box is no longer the size that we need it to be, so we need to reset it so that it's the size of our solid. Then we'll take it. Actually, we probably want this to be a constant. Well, we'll see. It actually might not matter. So there we go. Let's look at this and look at our render, and hopefully, all right, this has shrunk it down so far that it no longer looks the proper size. Well, let's set this to 0.5 instead of what it was. This hopefully will, this has reduced the resolution a little bit, but hopefully nope, we're going outside. The frame still. So the big problem we have here is that, of course, the gimmick plugin or the gimmick extrude is rendering this too big. So what we need to do is change its size here. So instead of 0.5, we need to shrink this down so that it's smaller. There we go. We'll take it down in here. 0.5, 0.4. Let's see if 0.4 is big enough. We want to keep this big for the purposes of making this, whoops, let's not rendering. Let's keep it big. We just don't want it to go off the edge of the screen at any point. All right, it came close, but it did not go off the edge of the screen. Now, as I say, all we need to do to make multiple types of shapes is we basically need to use the same kind of process on multiple things that represent the shapes we want. So in this case, we've got this SE noise shape here. That is this. And then we want to, now if we go back and we watch this, this is what it looks like. I mean, you could change your axes and whatnot for where this is, where these rotations are happening. But we could take this exact same node, plop this onto this sphere, and we can use this sphere if we take the resolution of this down a bit to something smaller. Uh-oh, whoops, that was 7, I think it was. I'm using the wrong one. I want to get this one. Drop this down to like 5 or 4, no, 5. Let's give it here and take a look at that. So we have 2 different shapes here. Let's take a look at this one. Now, admittedly, these are rotating in exactly the same way, in exactly the same direction, and so forth. So for each one of these, you would want to change up your variables, which axis is rotating which way. You know, do you want it to be a 24 frame, loop, or do you want it to be bigger? Anyway, the main point behind this is to show these are 2 different shapes. We've created basically the equivalent of 2 different particle shapes, and we can create an individual particle shape however we want. It doesn't really matter what we use. Is this going? I just want to make sure we're going. I don't see any activity on Facebook, and I'm a little concerned that people. Whoa. All right. Well, I'm not going to worry. Going to assume this is going. Going to just double check the stream over here. It says, according to my stuff, the stream is going well. It's just there's very little activity, which is unusual. Anyway, sorry. So where do we go from here? So we have these particles. What do we do with them? What can we make these particles do? How do we make these into like a field of particles? Well, now we're going to get into, there's a couple ways. We could use a gimmick node to sort of make particles, but there's a better node for actually making particles, and that's built into Natron. If we right click here and go into our extras, there is under here, I believe, where is it? Oh, transform tile. There we go. So tile. Now you're all saying to yourself, tile? Why would we use tile? Tiles are very useful very useful for what we need to do, because what we can do here in this tile is by just keeping it at 2, we can enter a time offset. Now, we know that each one of these samples, or this image, we have, this has built-in time offset, basically. So we are rotating over 40 frames. So if we want to make 4 different variants of the particle, we can make 4 different variants of the particle right here, just by simply taking the time offset here and setting it to something like, we want to do an odd frame. I highly recommend keeping it off. We'll do like 9 frames off, time offset by 9 frames, and there we go. And so now when we start playing this, we can see each one of these is perfectly offset by, they still rotate the same amount in 48 frames, but they're offset by 9 frames each, so they don't look 100% identical at this point. Now, they do look identical in how they rotate, but we're only creating full basic 3D particles at this point, okay? So we've just created 3D particles, but they're placed around. So we don't have them randomized across the screen. Well, how can we randomize these particles? Well, now I would argue that the best thing to do is to use, there's a couple things we could do. We could either use, let's try, here's what we're going to do. We're first going to duplicate this tile again. All right. I'm just thinking about this. Do I want to use a tile here? As I say, I had a project sorted. This is an investigation. I don't have this process entirely down yet. I think for our duplicated tile, we are... Oh, that's odd. We're going to reset this. And we're going to go over here and we're going to look at the second one. And you can see that it's created a set of 4 of these now, or it's duplicated this twice. And so you're saying to yourself, well, why would you do that, Part1? Why would you duplicate this twice so that it's you know, and you'll notice I did not time offset the second one, and I'm a little bit worried that this might be too time intense. I'm not positive. We're gonna compare a little bit here. You know, this might be one of those times that we can do render statistics and just look at what our render statistics are. And I'm trying to remember. Oh, boy, I'm not very good at this. Oh, I'm terrible at using this node. I don't use it enough. But you can use time spent rendering each accumulation is checked. All right, let's back this up. All right, there we go. All right, so we want to hit play. And there we go. All right, so it's telling when we hit play, we can start getting an idea of how much each of these tiles are taking. So the tile 1 is taking the longest. Tile 1.2 is taking, it's doing okay. We're getting about 12 frames a second. We're getting a decent amount. I'm just wondering if the second tile, I'm wondering if we can get a better result with a different node. All right, because there's 2 nodes that we could use to do what we're doing here. One is the tile node, which is native. The other one is a gimmick node. So in our gimmick node, actually, I'm going to right click, go into gimmick, and under our arrays, we have an array, and I think it's just regular, I believe. Yes, we're going to use array regular. And now we might run into a small problem here. No, it worked perfectly fine. All right, so we say array regular and just take a look at this. And array regular is basically the same thing. It's taking it looks like it's taking significantly longer. Let's rewind it and try and play this and just see if this is going to take longer to render. I can already tell it's taking longer to render. All right, so there you go. Just so we know, they both do exactly the same thing here, except for the gimmick node is taking much, much longer. We're getting almost 30 seconds. Oh, wait a minute. Wait a minute. This is way... These nodes are taking longer. Something is weird here. All right, let's go back to the beginning here and just try this again. And hit play. It's way faster. All right, we're getting much faster results with the using the tile node. So I highly recommend stick with the tile as opposed to the array node. All right, but that doesn't solve the problem. We still have a problem here. So you're wondering why do we have 4 of these? Well, the problem we have is that this is these are all in a predefined location, and what we want to do is we want to randomize this. Now, unfortunately, the only way to randomize this is going to be to use another gimmick node. And we'll go over to, let's make sure this is showing up, into the gimmick nodes, arrays and tile, and you can see there's this thing called gimmick array random. And we'll put the random on here by default in its default form. It's not going to be very useful. This is going to look very weird once it's done. It's going to take it a minute. That looks totally broken, and if we were to actually play through it, it looks weird. But we do know that our tile set here, this is a tile set of 4x4. So if we tell it for our gimmick node that the source input is 4x4, all right, like so, then when we go back to it, we wind up with each one of these randomly placed evenly throughout this entire here, let's look at this a little closer. We can see that they're randomly placed. We have this is the same thing as this and this. They're all randomly placed. It's picked between those, each one of those, the 4 items, and randomly placed it in this basically grid of stuff. The problem is again, we have this grid of stuff. And we don't want a grid of stuff. So how can we stop this from being basically a grid? And the easiest answer is we need to break this up somehow before we use this randomizer. So let's go back here to our tile map and think about this. What we want to do is, because we have 4 of these, we can take this and isolate or add things into this before we feed it into the gimmick node to block out certain ones to create more of a random pattern. How can we do this? Well, this is an area that I wasn't quite too on the other thing, and I was debating things. There is an array. There's a random color node inside of gimmick. One of the ways I was looking at doing this is to use a checkerboard. So as I say, we'll try a checkerboard. I'll show you what I was doing earlier, but I find that the checkerboard still winds up with some not so good results. So let's think about what we're doing here. All right, right here we have. Oops, right here. Excuse me. We have a 4x4 grid. All right. What we want to do is basically make it so that our checkerboard is basically a 4x4 grid of black and white tiles. So I'm going to sit here and I'm going to just say anything that's this dark gray, or that was the dark gray, I'm going to set to black. Okay, and anything that's light gray, I'm going to set to white. All right, let's whoops, right here, white. Whoops, hey, that didn't go. Hit cancel. Let's try that again. White. There we go. Sorry. And then what we're going to do is take it that we want this. We don't want a center line in it, so we want to just get rid of that by setting that to 0. And now we wind up with this grid. So now what we need to do is a little math here. Basically what we want to do is divide both of the axes by, we don't want this to be a perfect box. Instead of this being a perfect box, what we want to do is divide this so that we can get this to be, basically 4 of whatever our vertical resolution is by 4 of whatever our horizontal resolution is. So we know that our well, actually, let's do horizontal. We know our horizontal is 1920, so we divide it by 8, and that tells us that we want it to be 240. So for here, for our box size for X, we set it to 240. We just set 240, and that should, we don't want it to be, that's actually less. Wait a minute, is that right? Wait a minute, I think I screwed that up. 4, but did I do 8? I think I divided that by 8. You know what it was? I looked at this 8 right here, and 1920 divided by 4, 480. So we want this to be 480. 480, and there we go. Wait a minute. Oh, we're not looking at the thing. There we go. 480, and then we want to say take the same thing, and we want to do horizontal or do the vertical, which is 1080 divided by 4. 270. So we go back into this and we say 270 here, and there we go. There's our block. So we have this. Now we want to use that as the mask. Well, the good news is if we just create a mask here, if we put a merge node, put the A channel into our tile set, and then just put the mask in here, hopefully, we would hope, but it does not work that way, it seems. So we're not getting an alpha channel in here. The alpha here, it's keeping the original alpha from our original source, which is A. Let's see if we remove that. Nope. It doesn't work. All right, so we'll have to do this a different way. All right. So what we can do is instead of mask, we can just take this and put B in there, and then we can just say multiply. If we multiply the two, what we've done is we've eliminated half of our things. Well, that means that we could, in theory, because we've offset this by taking this and plugging it in, now, because every black thing is getting randomized, we are winding up with them at random locations. It's still too patterned, in my opinion. And I hadn't gotten much past this point. And so for today, and I think because we're approaching the 1 hour point with this particular episode, we're not quite. Let's see, we're at 51 minutes. Yeah. I think this is going to be the point at which we're going to probably stop this. But let's just look at what this is doing at this point, so we can investigate this future. Because there's also another announcement I want to do. Oh, that's interesting. Okay. That's weird. It does not look like they're actually offset by all that much. It looks like it took the exact same node, or the exact same two. Oh, you know what it is? I'll bet I know what it is. Yeah, it's using... All right, the problem is we're blocking out two that are very close to one another. All right, so what we may actually want to do is change our mask so that... let's see, 270. Let's just, for the vertical, let's set it, instead of 270, let's do ×2. There we go. That will change it so now we're using 2 like that instead. And hopefully that will create more of an offset. And when we go over to our other, it changes the pattern up a little bit. And this was one of the things. There we go. This is a bit further off, but we still don't have enough variation to it. So what we really want to do is randomize the checkerboard ahead of time. And actually, I'll just show you what my first thought on doing that is. There's a lot of ways we could do this, but one of the interesting things is we could just take this and use it to randomize itself by setting this, instead of 7 by 7, if we just take the input number, whatever our input is, and tell it that we want that to be our output, we wind up with a pattern like this. And then when we run that through, we wind up with this for our final pattern. Now, admittedly, the big problem is this does not have a way, as far as I know, maybe it does. We can't change... oh, wait, maybe we can change the random seed. Oh, we can! Excellent. All right, so we can change the random seed. I was worried that there wasn't going to be a way to change the random seed, but we can go in here into the advanced options and change the random seed and go through this and figure out what what pattern we want for this. So that's going to be really useful from the standpoint that we can pick and choose which ones of these, which set we want. And it means that we can create multiple sample sets for this. We can create, just using this same gimmick array, we could create multiple, we can use this one input and create multiple outputs, so we can get different potential varieties of these. Of course, we've only made 4 variants of this, but we could, in theory, increase our tiles here even higher. There's nothing that says we have to stick to just 9, or just a 2x2, which is 4, and then doing the same thing again. We could have just done it once. We could go back here instead of doing it here, instead of doing it here 2 times, we could tell it we wanted to do it 4 times. And now we, not 3, 4 by 4. And then we wind up with something. Now we wind up with this, which is looks a lot more random. And we get something, just using the one thing, we wind up with a bunch of variants here, and then we could randomize that around our screen. So anyway, enough of that. I think we've gone as far as we need to go in today's tutorial or exploration, because this is going to be a complex process. Ultimately, what we're going to be doing is we're going to be using this particle system that we make here in something else. We're going to use it inside of, we're going to actually make it so that when we're going to, this is, I forget who did the actual original tutorial on this, but we're gonna eventually basically make some things that where there's like a laser blast going across a font. That's been a very requested tutorial that requires 3D particles in order to pull off, and or pull it off the same way it was in this particular, animation. Anyway, enough of that. Enough said. We're going to the goal today was to sort of start exploring how we might go about making 3D particles. We've started doing that. We are seeing it here. This is a little, these are rendering on a little bit on the slow side. We could, in theory, actually just use something simpler and and it would probably render a little bit faster. Not much faster, but as you can see, even just switching to that, I think that actually, this is rendering almost twice as fast as it was a few minutes on the previous version, all because we're using a simpler shape. So remember, the simpler we get our shapes, the easier this is going to be. In fact, I would argue that we could bring this to all the way down to a much simpler shape. Let's bring it down to even, let's try 2. No, let's keep it at 3. And just look at what that does. See how that works. Does that actually render faster? Just curious. Oh. It's taking it a minute. It's got to think. There we go. So there we go. We're seeing it, and I don't want to dwell too much, but yeah, we're getting something that could work as 3D particles. All right, so there we go. There we have it. The beginnings of 3D particles and how we might go about doing it. Of course, we've got to randomize these a whole lot more and get it so that they spread out across the screen, and that's for the next video. So. Oops, we don't have. That's wrong. Today's goal. I hit the wrong thing. There was no today's goal because it blew up on me. So, thanks for watching and keep on Natroning.